In this video, I'm going to show that if A divides B and B is not equals to 0, then the absolute value of A is less than the absolute value of B. So to show that, I'll use the definition of a divisibility. By definition, A divides B if there exists an integer C such that B is equals to AC. So I'll write it down there. There exists an integer C such that B is equals to AC. I can go on and take absolute values on both sides of this equation so that we have the absolute value of B is equals to the absolute value of A times C. And this part we can separate it by properties of the absolute value so that we have the absolute value of B is equals to the absolute value of A times the absolute value of C. But in this question we are given that our B is not equals to 0. So I'll write my B there is not equals to 0. So if B is not equals to 0, we are having the left hand side here is not equals to 0. So if the left hand side is not equals to 0, then the right hand side there is not equals to 0. So if it's not equal to 0, then it would mean that the C there, our integer that we are looking at, is not equals to 0. So if C is not equals to 0, here in this equation we are taking its absolute value. When we take the absolute value of an integer which is not equals to 0, then that absolute value will be greater than or equals to 1. So we are having this part here is greater than or equal to 1. Now looking at this equation here, I can just make A subject to the formula. Then we have A is equals to the absolute value of B divided by the absolute value of C. But we are saying to get A, we are dividing it by this absolute value of C. But we are saying the absolute value of C is greater than or equal to 1. So that means when we divide the B by something which is greater than or equal to 1, the result that we get there is something which is smaller than the absolute value of B. So in this case, we would get that the absolute value of A is less than the absolute value of B.